Dear students, we were discussing about the interaction of heavy charged particles with matter, and today we are going to discuss about the secondary electron emission from surfaces. So when charged particle passes through matter, the kinetic energy decreases and they get slowed down. Many electrons from the absorber atom gain sufficient impulse to travel a short distance from the original track of the particle. Delta rays, which have high energy to ionize other absorber atoms, and electrons having kinetic energy which is below the minimum energy for further ionization, is included in this category. Some of these electrons migrate to the surface and have sufficient energy to escape when an energetic charged particle is incident or emerges from a solid surface. Such escaping low energy electrons are termed as secondary electrons. Hundreds of such secondary electrons are produced by a single heavy ion such as a fission fragment. Lighter alpha particles produces 10 or few secondaries per particle. Fast electrons such as beta particles are much less likely to create such secondary electrons, and only a few percentage will cause secondary electrons. And how much secondary electrons are produced or yield of secondaries will be proportional to the energy lost by the charged particle within a surface layer. The thickness of the surface will be equal to the maximum distance an electron tend to migrate from its point of origin and escape from the surface. Thus, dE by dx value of the particle predicts the secondary yield from a given material. Materials with low work function and large escape distance will produce maximum secondary electrons. For example, thin films of alkali halides and cesium iodide produce more secondary electrons. The energy spectrum of such escaping secondary electrons is a continuum, but their mean value is very low compared with the primary particle energy. The energy of secondary electrons from a carbon surface with alpha particle is 60 to 100 eV, and for fission fragments it is nearly equal to 290 eV. The energy of the secondary electrons produced by lighter particles such as fast electrons is lower. So it is difficult or impossible to observe these secondaries as they are reabsorbed even in air. But if they are emitted into vacuum or low pressure gas, they are accelerated and easily guided by electric fields because of their low initial velocity. Because of this property, secondary electron emission from surfaces is used as a means of detecting the positions at which beta particles emerge from a surface. It is also used in imaging of X-rays and fast electrons. That's all.